Hazardous chemicals can hurt you in a number of different ways, but we normally classify them as either physical hazards or health hazards. Physical hazards are substances that can injure you by catching fire, exploding, or reacting dangerously. Health hazards, on the other hand, are things that can affect your health adversely, either immediately or over a period of time. In a previous program, we looked at kinds of physical hazards that usually need some outside factor to set them off, such as ignition or shock. Today, we're going to talk about types of physical hazards that can activate on their own or react dangerously with other substances. These include chemicals called oxidizers, organic peroxides, and pyrophorics. This HAZCOM glossary is a handy reference you can use to understand the various terms used to define hazardous chemicals. Let's look up unstable first. That's a chemical that has a tendency to decompose or undergo some other undesirable chemical change during normal handling or storage. The reactivity of a chemical means its tendency to release energy from contact with other materials or from heating or burning. These reactions can create hazardous conditions such as pressure buildup, excess heat, and toxic or corrosive fumes. Now, to help you understand more about unstable and reactive chemicals, let's go to our resident expert, Professor Sharp. Professor?
Thank you, Barry. We discussed how chemicals can be reactive with themselves and with other substances. Our HAZCOM glossary tells us about specific kinds of reactions that are referred to in material safety data sheets. Now, unstable chemicals can polymerize, a reaction in which the molecules of the substance start combining with each other. If this reaction becomes uncontrolled, great amounts of energy can be released. Styrene is a perfect example of a chemical that has a tendency to polymerize. Other unstable chemicals have a tendency to decompose or break down when exposed to heat, chemical reaction, or decay over time. Now, this decomposition reaction can become quite violent and generate dangerous amounts of heat or toxic gases. To protect people from unwanted reaction, inhibitors are often mixed into unstable chemicals to slow down hazardous reactions. For example, an inhibitor is added to styrene to prevent polymerization. Now then, let's look at some types of reactive and unstable chemicals you might come in contact with. Chemicals called oxidizers can be especially hazardous if they're not controlled properly because they readily yield oxygen that can create or support combustion or even cause an explosion. Now, some common oxidizers are ammonium nitrate, which is used in fertilizer, and hydrogen peroxide, which is a common household disinfectant in a weak solution. Acetyl peroxide is an example of an organic peroxide, which can react explosively if involved in a fire. Besides oxidizers, there are other classes of unstable or reactive chemicals, and each presents hazards. Metal hydride, for instance, will react violently with plain water or even moist air. As with any chemical, the best source of safety information is from labels and material safety data sheets. Now here you see Department of Transportation labels for an oxidizer and organic peroxide, both with flame symbols. Here's an MSDS for a strong solution of hydrogen peroxide. At the top, you can see that it's unstable. Now, the other sections tell you what conditions to avoid and what materials are incompatible with hydrogen peroxide. Well, that's enough of our video classroom for right now. Back to you, Barry.
Knowing how unstable and reactive chemicals can injure you helps you take the proper precautions when handling them in your job. Although we're focusing on physical hazards in this program, these chemicals can also react in ways that produce toxic or corrosive byproducts that are health hazards too. Now we're going to see a demonstration of reactivity of certain chemicals. We have Stuart Sims, a research chemist with Standard Laboratories, standing by. Stuart, I understand you're going to show us how some chemicals can react in dangerous ways.
Yes, Barry, I have some samples of reactive chemicals here to demonstrate. This bottle contains chromic acid, a powerful oxidizer. Watch what happens if some of it spills on ordinary paper trash. As you see, the paper will heat rapidly and eventually catch fire if the reaction is not extinguished. Some chemicals react violently when they come in contact with water. Sulfuric acid is one of these. Watch what happens when we combine the two. Now here are two common household cleaners, chlorine bleach and a common bowl cleaner, harmless enough by themselves, but if we mix them together, they react to form life-threatening chlorine gas, notorious for its use against troops in World War I.
Obviously, Stuart, following proper storage and handling procedures as outlined in the MSDS is the best way to prevent dangerous reactions like those. But what if a potentially hazardous reaction does take place? How can you spot it?
Well, there are detection devices used, such as electronic sniffers and smoke detectors. However, there are several ways anyone can spot trouble in their workplace if they are alert. If you smell an unusual vapor odor, it could be flammable, toxic, or both. Report it immediately. Also, if you see chemicals leaking from a container or pipe, smoke is a sure sign that a hazardous reaction is taking place. And excess pressure or temperature buildups are often signs of a hazardous reaction inside a container. Or a physical deformity, such as a bulging drum, could be a sign of trouble.
In other words, it pays to be observant on the job.
That's right, Barry. Using your eyes, your ears, your nose, and your common sense.
Thank you, Stuart, for that good advice. Proper identification of reactive chemicals, following safe handling practices, and knowing what to do in an emergency can prevent a disastrous accident. What can happen when these precautions break down? Perhaps no more graphic example is available in real life than the catastrophe at Texas City, Texas on April 16, 1947. For that story, we're going to interview Mr. Ezra Stokes, who remembers that fateful day and its aftermath all too well. Mr. Stokes, I understand you were working as a chemical engineer at a plant near Texas City back then.
Yes, and I'll never forget that day if I live to be 100. You see, there was this French cargo ship, the Grand Camp she was called. It docked at Texas City and loaded up about 2,300 tons of ammonium nitrate in paper bags, just like these. You see what that label says?
Well, there's sure no warning sign on it. Looks like harmless fertilizer, doesn't it?
Well, back then, folks didn't think it was dangerous. Oh, they knew it was used as an oxidizer and high explosive, but nobody thought it could be detonated just by heat or fire. Why, there weren't even any no smoking signs aboard that French ship. Well, anyway, one of the crew saw smoke coming out of the hole. They dumped a little drinking water on it and hit it with a hand extinguisher to no effect. So then they were going to flood it with water, which was the right thing to do. But they didn't want to ruin the cargo. So they battened down the hatches, sealed the ventilators, and turned on the ship's fire-smothering steam system. All that did was raise the temperature and fuel the oxidation. Pretty soon the hatch covers were blowing off due to the pressure, and the thick orange smoke was pouring out. Well, that was due to the burning chemicals decomposing into nitrous oxide, you see. Finally, the city's volunteer firemen arrived on the dock, along with a whole lot of sightseers. About the time the firemen started laying out their lines, why, all hell broke loose. Yes, sir, that ship blew up like an acre of TNT, while people heard it 150 miles away, and it registered on a seismograph in Denver, Colorado. You see, that ammonium nitrate had been allowed to reach just the right combination of heat, pressure, and contamination from the burning paper bags and wood in the holes, and it did the unthinkable. It detonated. Why, that explosion was so powerful that it ignited the Monsanto styrene plant across the harbor, where they were storing highly flammable benzene and propane. Why, it knocked two small planes out of the sky, and they found a 10-foot section of the Grand Camp's propeller 4 miles away. So the burning debris ignited another ship, the High Flyer, which was also loaded with ammonium nitrate and sulfur. Several hours later, that ship exploded. caused by a different reaction caused by the burning sulfur. All told, 552 people were killed, 3,000 injured, and the damage cost over $50 million. And that's $1947.
Incredible, Mr. Stokes, and a terribly costly lesson in the hazards of reactive chemicals, wasn't it?
Oh, yes. Now we have warning labels and MSDS on ammonium nitrate and other such chemicals. You know to keep its temperature down. And if it burns, to douse it with water, not steam. If only people that were handling this stuff would pay attention to what they're doing.
That's what HAZCOM is all about, Mr. Stokes, understanding and using what we know. Thanks for being with us. The primary methods of controlling unstable and reactive chemicals are segregation and containment. But how do you know which chemicals need to be segregated from each other in your workplace? The MSDS and your company's special handling procedures are two very good guidelines. Now Professor Sharp has some information about chemical incompatibility.
Welcome back. Professor Sharp here again to discuss an important characteristic of unstable and reactive chemicals, that being incompatibility. As with people, some chemicals just don't get along well together at all. Now, HAZCOM glossary here says materials are incompatible if they can cause dangerous reactions from direct contact with each other. The U.S. Coast Guard publishes an excellent guide to the segregation of hazardous chemicals called the Chemical Compatibility Chart. Let's see how it works. Here you see the listing for toluene, for example. Now, following this column, we find an X under inorganic acids, such as nitric acid. Now, that's because toluene and inorganic acid can cause fire or explosion if mixed. Here's another example. Ammonia. Over here, we see an X under aldehydes. That means if you mix formaldehyde with ammonia, you get an undesirable reaction. Fire and toxic gas in this case. So you can see how the compatibility chart is a valuable source of information about storing and handling reactive chemicals safely. Well, that's about all for now. Barry?
By using the information on labels, MSDS, and the compatibility chart, you should always know when you're dealing with unstable or reactive chemicals and how to spot unsafe conditions. To find out some of the ways unstable and reactive chemicals can be safely stored and handled, we have another interview lined up for you. We're going to talk to Jack Snyder, a safety engineer with a chemical distribution company. Welcome to the HAZCOM report, Jack. I imagine you have a number of hazardous chemicals to deal with in your warehouse.
Well, yes, we do, Barry. In our business, we depend on the manufacturer's MSDS for each chemical we store to determine how to handle it safely. With unstable and reactive chemicals, there are several general guidelines we follow. The first principle of good storage practice is segregation, keeping non-compatible chemicals away from each other. So if there is a leak, they won't react dangerously. Next is to be sure each chemical is stored and handled in the right type of container. High temperatures can cause hazardous reactions in many chemicals, so we make sure the area is well ventilated. And we want to keep them out of direct sunlight for the same reason. We train our employees in safe handling practices, so there's less chance of damage to a container that could cause a leak or spill. To control any fire, we have sprinklers and several different types of extinguishers, depending on the chemical involved. And finally, we provide proper protective equipment to our employees who handle these chemicals.
What about those containers, Jack? Could you show us some examples?
Sure. Containers are designed to control the hazardous properties of many unstable and reactive chemicals. Many acids and bases are very reactive, so they are stored in containers like these. Because acids react with most metals, the container is lined with an inert plastic. Oxidizers, such as organic peroxides, present a special problem because of their flammability and explosiveness. They are usually stored in plastic containers, like this one. Pyrophoric metals are another type of substance requiring special containers. Pyrophoric, such as triethylaluminum, will ignite spontaneously with air. So these containers have a nitrogen gas blanket over the chemical to inhibit contact with oxygen.
You mentioned personal protective equipment earlier, Jack. What measures do company employees use to prevent injury when handling some of these chemicals?
Many unstable and reactive chemicals, by their very nature, can cause corrosive burns, burns from fire, and many of them decompose to produce toxic fumes. Protective gloves and a face shield are always a good idea when handling these chemicals. The gloves protect the skin from any residue that may be on the containers, and the face shield protects the eyes and face from splashes. Two kinds of breathing apparatus are available, a simple air mask or a respirator, and this self-contained breathing apparatus for use in case of spills or fires. When loading or unloading corrosives, we use full protective clothing, like this acid suit.
Looks like your people are well prepared. Thank you for joining us, Jack. That winds up our coverage of physical hazards for this edition. In this program, we reported to you about controlling the different types of unstable and reactive chemicals you may come in contact with in your work. Professor Sharp showed us how to find information about the reactivity of chemicals on labels and material safety data sheets. We visited a research chemist who showed us what can happen if reactive chemicals are mixed, even in the household. We saw the real-life tragic consequences of failure to control a reactive chemical in the Texas City disaster. Because proper containment is so important in controlling reactive chemicals, we investigated how these materials are stored and handled. In future editions of the HazCom report, we'll cover health hazards and how you can protect yourself from them. But for now, I'm Barry Lerner, and this has been the 7th in our series of HazCom reports. Thank you for watching.